Alright guys, in this video, I'm going to show you how to solve or prove problems involving trigonometric functions. But first, what do we mean by trigonometric functions? In mathematics, the trigonometric functions are real functions which relate an angle of a right-angled triangle to ratios of two side lengths. The trigonometric functions that are most widely used in modern mathematics are the sine, the cosine, and the tangent. Their reciprocals are respectively the cosecant, the secant, and the cotangent, which are less used. Each of these 6 trigonometric functions has a corresponding inverse function and an analog among the hyperbolic functions. In solving or proving trigonometric functions, we need to know first the trigonometric identities. We have the reciprocal identity, the quotient identity, and the Pythagorean identity. Knowing these identities will be a big help to prove problems involving trigonometric functions. Now that you know the meaning of trigonometric functions and its identities, let's now solve and prove some problems involving this topic. Our first problem to prove is 1 plus cotangent squared theta is equal to cosecant squared theta. To prove if the left side is equal to the right side and vice versa, the first thing that we need to do is to identify the side that is more complicated. In this case, we can see that the left side is longer, right? Since it looks much more complicated, we are going to make it equal to the value of the right side, which is cosecant squared theta. As we can see here, cotangent squared theta is the same as cosine squared theta over sine squared theta based on the quotient identity. Since they are equal, we can now change it into cosine squared theta over sine squared theta. Now that we have 1 plus cosine squared theta over sine squared theta, we can add these two already using cross multiplication to have sine squared theta plus cosine squared theta over sine squared theta. The next thing to do is to look at the numerator. Can we find something in the identities that is equal to sine squared theta plus cosine squared theta? Yes! Based on the Pythagorean identity, sine squared theta plus cosine squared theta is also equal to 1. Now that we have 1 plus sine squared theta, we can now look at the identities if it has an equivalent. If we are going to look at the reciprocal identity, we can see here that 1 over sine theta is equal to cosecant theta. Since we have an exponent in the problem, we can just also add an exponent to cosecant theta to have cosecant squared theta. Being said, we can already prove that the left side is equal to the right side. Moving on, our next problem to prove is cosecant theta over cosecant theta minus 1 plus cosecant theta over cosecant theta plus 1 is equal to 2 secant squared theta. Again, let's first identify the more complicated side. In this case, it is very evident that the left side is much more complicated, right? Which means that we are going to prove if this side is equal to the other side. To start, we need to add these two fractions using cross multiplication to have cosecant squared theta plus cosecant theta plus cosecant squared theta minus cosecant theta over cosecant squared theta. Before moving on, let's arrange the variables in the numerator from greatest to least first to have cosecant squared theta plus cosecant squared theta plus cosecant theta minus cosecant theta. As we can see here, we can just cancel positive cosecant theta and negative cosecant theta since they have opposite signs. just add the 2 cosecant squared thetas to have 2 cosecant squared theta over cosecant squared theta minus 1. If we are going to look at the denominator, we can just change it into cotangent squared theta since it is equal to cosecant squared theta minus 1 based on the Pythagorean identity. In this case, we will just multiply the numerator to the reciprocal of the denominator. But first, let's extract the 2 from the numerator. Now that we have cosecant squared theta over cotangent squared theta left, we just need to find the equivalence of these in the trigonometric identities. Since cosecant squared theta is equal to 1 over sine squared theta, we can now change it. On the other hand, cotangent squared theta is equal to cosine squared theta over sine squared theta. However, since we are going to multiply now instead of dividing, we have to get its reciprocal. At this state, we can now have 2 times 1 over sine squared theta times sine squared theta over cosine squared theta. Just cancel the sine squared theta for us to have 2 times 1 over cosine squared theta. Now, we can already find the equivalent of 1 over cosine squared theta, which is secant squared theta. Just multiply it to 2 for us to have 2 secant squared theta. Being said, we can now already prove that both sides are equal. And for our last problem, we have cosine theta over 1 minus tangent theta minus sine theta over 1 minus cotangent theta is equal to sine theta plus cosine theta. Now, to solve this, let's use the left side since it is the much more complicated side. Let's focus on the denominator first. We can see that we can turn the tangent theta into sine theta over cosine theta, while we can change the cotangent theta into cosine theta over sine theta. At this point, we can now subtract the variables in the denominator to have cosine theta over cosine theta minus sine theta over cosine theta minus sine theta over sine theta minus cosine theta over sine theta. Confusing, right? But now, the next thing to do is to simplify the fraction or just simply multiply the numerator to the reciprocal of the denominators. If we do that, we will have cosine squared theta over sine theta minus cosine theta minus sine squared theta over sine theta minus cosine theta. Since the two terms are similar fractions, just subtract the numerator, then copy the denominator to have cosine squared theta minus sine squared theta over sine theta minus cosine theta. Now, as we can see here, the numerator can be expanded with the use of the product of sum and difference to have cosine theta plus sine theta times the quantity of cosine theta minus sine theta all over sine theta minus cosine theta. Just cancel terms since they are similar for us to prove that the left side is equal to the right side. And that's it for this video. I hope that you learned something and I hope that you will be able to apply this topic into your life. Thanks for watching. Bye!